Okay, so happy birthday, Bitcoin Wednesday. I'd sing to you, but I'm not much of a singer. I'm much better at technology, so I'd rather talk about that. So my name is Henri. I'm founder and CEO at Streamr. And I'll tell you what Streamr does in a couple of sentences. And when I do, you'll be like, wow! But what does it mean? So after that, I'll explain what it means. So we aim to tokenize real-time data streams in order to make them tradable by machines and people. And this requires that we make a scalable, decentralized messaging infrastructure, which is trustless. Wow, sounds great. Okay, so now let's take a couple of steps back to the early, dark, medieval times when I was an algorithmic trader, as you heard. So I made infrastructure and algorithms for the specific use case of listening to data streams coming in from the stock exchange and making autonomous decisions about whether to buy or sell a stock. And this was the time when I realized that actually newest data carries intrinsic value to somebody. In this case, to the traders. They cannot trade with old data or even delayed data. They need the fresh data. I also realized that there's value in being able to automatically react to that data. Now, fast forward a couple of years, and everybody starts talking about the IoT and the massive explosion of real-time streaming data in the world, produced by millions and millions of sensors globally in the world. So we started thinking, okay, could the same kind of principles, same kind of patterns be applied to more general data streams? Kind of do what we did while we were trading, but apply that to data streams in general. So a sensor could be emitting data. There could be an algorithm that makes decisions about, well, for example, if a device is failing, if your diesel engine is broken, if somebody broke into your house or whatever. And this also carries intrinsic value. But that value is difficult to extract from the raw data. It requires the algorithm and the delivery network to be in place. And Streamr is not native. Streamr is not native to the blockchain community. So we first started to make cloud infrastructure and a cloud-based tool, so distributed, scalable tool for data delivery and real-time analytics. And it looks like this. So we have a visual editor in there. There's a box that is a data source, and you can connect the fields in that data source to various modules that do some kind of operation on that data. You can also do visualizations. You can do actions such as API calls and things like this as the outcome from the processing chain. Now, what does this have to do with the blockchain? Well, say a year ago, we got super excited about the blockchain, the decentralization, the smart contracts, and the promise of tokenization of value in different business verticals. And of course, coming from the data perspective, we were instantly interested in how to tokenize streaming data. And I'll talk about that a little bit later. But now I'd like to show you a live demo of what we have currently. So we started experimenting with Ethereum integrations and built them into our platform. So let's build a big data-driven smart contract. Sounds impossible due to the scalability issues already discussed. But if you combine off-chain and on-chain computing seamlessly, it's of course possible. So let's see what happens. Um, can you? I'm going to be operating the computer, so I'm going to need someone to hold a mic. So I have the best microphone stand in the world here with me today. Okay, so let's see. This is, I'm going to zoom it up a little bit. You'll probably be able to see at least something. So this is the Streamr editor. This is an environment where you build data processing chains, right? So I'm going to add a data source. It's called public transport demo. Now this is a data stream that contains telemetrics being sent from public transport vehicles in Helsinki, where I'm from. I'll show you. I'll add a map. It's a geographic map. Now in the data stream I have a vehicle ID. I'm just going to connect it with drag and drop to the ID input on the map. There's also latitude and longitude fields. I'll connect those as well, and I'll hit start. Okay, so we'll be able to see what's in the stream. So all the trams in Helsinki are sending their location, ID, speed, and heading like every second or so. So we're getting quite a lot of data in there depending on the time of day. And if the Wi-Fi permits, we should see the trams moving there as well. Now, if we want to make, let's make a simple use case out of this, just to demonstrate something. So we'll make a kind of a micropayment demo here using an Ethereum smart contract. So in this imaginary use case, let's say that I am the city of Helsinki, and I'd like to have a tram operator run their trams in Helsinki. And instead of making a standard paper contract saying that I pay them 2 million per year for them to run the trams in our city, we could do that, but I wouldn't get any guarantee of anything that they actually do. No quality of their service, no mileage actually traveled or anything like this. So instead, let's make a data-driven smart contract. Since we have these sensors on board every tram, we can use that data to make payments based on the distance covered by the trams, for example. So let's do that now in 5 minutes. We're getting the raw data in from here. I'll just stop this to be able to build something. So we're getting in the coordinates. Of course, we could calculate the distance traveled by a tram from the coordinates, but that's pretty crappy because the GPS isn't very accurate. So instead, we can use the speed, which is quite accurate, and the time between subsequent events. So speed multiplied by delta time equals distance, right? High school physics. So I'll add a module called for each. So for each tram, we need to calculate the distance traveled. I'm going to load up an abstraction that I did earlier just to save some time. I can show you what's inside. So inside this box is a couple of more boxes. So you can do like hierarchies here. I'm going to connect the for each key to the vehicle ID. So for each vehicle, we calculate something. And I'm going to connect the speed over there. OK, so now I'm going to add a table to see what's coming out of this box. So I'm going to connect the table to the distance and hit start again. Or actually, let's connect also the key so we can see that the trams have identifiers. OK, so I'm getting a view on the data stream coming from this box. So we have the identifier and the distance is covered by the tram between subsequent events sent by that individual tram. Now, of course, we could already use this as a basis for payment. But as you can see, there's quite a lot of stuff coming in from there. So we definitely don't want to make a blockchain transaction for each event coming in here. If we have let's say we have 400 trams running and each one sends an event per second, so that would be like 400 transactions per second pushed to the blockchain. So not doable. So here's the power, of course, of combining the off-chain analytics here. So I'm going to add something a little bit pre-made as well to save time. So I'm going to add something that I labeled the accumulator. So what we want to do is add up those distance increments up to a threshold and then commit that to the blockchain. We could do the same based on time, for example, commit every 10 minutes or so, but that wouldn't make any sense during the night when the trams are not running. So it's much more usable to set a kind of a threshold in terms of the actual basis for the payment. So I'm going to connect the increment to the distance, set a parameter here, let's say 1,000. And what I'm going to do now is add a chart. And in the end of this chain, we'll add the component that actually talks to the blockchain, so bear with me. I'm going to add the current value to the chart so we know what's happening there. So there's two outputs on my accumulator. There's a current, which sends out a value on every update. And there's a batch output that sends value when the threshold is reached. To verify that, I'll connect the batch output to the table to see what's happening. I'm going to set a threshold of 1,000 and hope that it won't take too long to fulfill. So every kilometer traveled would now result in a transaction to the blockchain once we make that part. OK, so now something interesting that we have here as a result of our experimentation with the Ethereum blockchain is a module called Solidity module. And what happens here is we can bring in a smart contract which appears as a module on the canvas. So we can actually connect off-chain things to a smart contract just as if it was a normal off-chain object. And also the outputs from the smart contract, such as events or return values, we can connect back to an off-chain process or another smart contract that lives somewhere. So on the Solidity module, we can have a code editor, write our code. I'm going to use a template that we have. We're trying to make these reusable kind of use cases. Here's one called pay by use. Now, pay by use is analogous to what we're doing here because we use some kind of measurement as a basis for payment. So, OK, now we reached the kilometer here. Good. So we can inspect the code. That's fine. I'm going to select an Ethereum account that I defined earlier. Just a sec. OK. I'm going to need an address where we want to pay. So this would be the address of the tram company. I'm going to just select some account that I have somewhere. This one, maybe. Now, in this smart contract, we set in stone the price per each reported unit, right? So it's uncheatable in the sense from that point on. So let's say it's 100,000 Wei per meter traveled. I'm going to give the contract some Ether to play with, and I'll hit deploy. So what happens now is that the block is being mined on the Ethereum blockchain, and once that's complete, I'll be able to interact with this smart contract. So while waiting, I'm going to add a module called Ethereum call. And this we will use to call our smart contract. So we can see from the chart that the threshold is being reached and the counter is kind of resetting back to 0. And when it does, it emits an event from the batch output. OK, now our contract is ready. We can see its address over here. We're going to call a function called update, which if we inspect the code, see that that's the function that issues or implements the logic of this. And I'll connect that to the batch out. Okay, so now we have a complete system. Okay, we have a data source. It's coming from the Public Transport Authority in Helsinki over the MQTT protocol, which is something that's commonly used in IoT. We had some analytics in between that does computation on the raw data, and we're as an endpoint for this chain, we're using the blockchain to issue payments to the tram operator. So we can set this running for a while. The smart contract can trigger events, which should also appear here after the block is mined. So this is where we are at the moment, and this runs on cloud infrastructure. So it's a scalable, horizontally scalable infrastructure, but there's one problem. It's run by us. Okay, so it's distributed, but it's not decentralized. So that's what I'm going to talk about next. So let's see whether we're going to 100 very soon. It's almost like looking at the Bitcoin price. Yay! Okay, there's a new row here. So now there should be a transaction that's being mined regarding the payment. So we can go to a block explorer and see that actually something is happening over there. If the gods of Wi-Fi are permitting. Okay, so there's a pending transaction, which is the update call that I made. And once this block is mined now, I should see the result here as well. So something has been paid over there. So this is actually, this is online. If you want to go and play around with it, please do. It doesn't need to be a blockchain project that you're doing. It also works for more traditional real-time analytics stuff. But of course, we'd love your feedback on the experimental blockchain features in there.
Do you get the data directly from the public authority?
Yeah, and we also have an API where you can post your own data. So you can create a data stream, start sending data to that stream, and instantly start building logic in the editor. Or you can connect to an API that already exists, maybe an HTTP API or something else, and start building it from there. So long story short, this is what we experimented with. Thank you for my gorgeous microphone holder. Thank you. So, for the past 6 months, we've been thinking, what would be the kind of version 2.0 of the Streamr infrastructure? So right now, we are running it, and if you want to use it, you basically have to trust us. I'm not saying that's bad, but you do. So what we'd like to do, or let's say, a slogan of Ethereum is unstoppable applications. But how do you get unstoppable data to those unstoppable applications? I mean, applications without data are just like half-assed things, you know. So how do you get unstoppable data to unstoppable applications? You could use the blockchain for data distribution, but that's just insane. We all know that it will never scale and it will be too expensive. So what we need is a network, a layer on top of the blockchain that can handle the data distribution part. And it will have ties back to the blockchain for certain functionalities. So we can get the best of both worlds in a sense. We can use the blockchain for consensus. It's good at that. We can use it for permission control. We can use it for identity. We can use it for data integrity verification, but we cannot use it for actual raw data distribution. If we want to go to millions of events per second, Simply not possible. So this infrastructure layer is something that is required to be able to solve this shape of problems where real-time data is streaming in. It needs to be delivered to the subscribers or recipients in a timely fashion. Now, something that the blockchain technology also enables is tokenization of the value in the data streams. And this can be implemented and used in a long chain of refining the data. So let's, for example, say that a stock trader or a crypto trader is subscribing to raw data from a crypto exchange. They maybe have a new algorithm or a prediction model, such as the one presented before, relying on GitHub metrics. And they could use this algorithm and produce data to another stream where subscribers could buy that data and start using it for their trading. Or you could have the raw components, such as the GitHub metrics there as a stream to enable people to easily start using that data to build something else. Or, well, let's say, let's see about a machine-to-machine scenario. Let's say you're a wind power generator, for example, and you're producing electricity from wind, but to operate efficiently, you might need some data to improve your operation. So you might want to buy, for example, a weather forecast. You might want to buy the price of electricity on an electricity market. And in this case, if you have a unified API for data delivery and also the monetization, the payment built in there, machines can actually transact exchanging data streams or permission to receive a data stream for tokenized value on the blockchain. So this enables a machine-to-machine data stream economy to emerge. And for this to work, there needs to be a cryptographic token that represents the value in the data stream and the delivery of that data. And we're proposing a token for this. We call it the Datacoin. I know that there's a Datacoin that previously exists, but it's kind of dead, so we thought we'd just steal the name, if that's okay. Or maybe we rename it to something else. I don't know. So using Datacoin, we can build a network of nodes that we call brokers. And this is similar to the nodes in Ethereum or Bitcoin. But those nodes are mining. They're coming up with hashes and trying if they're right. But these nodes actually perform the task of receiving data from data publishers and other nodes and pushing them forward to other nodes or the data subscribers. So these nodes can be incentivized using the token to perform a service for the network. And the joint operation of all these brokers actually forms the peer-to-peer data delivery network that underlies the whole idea. And all these brokers can be connected to Ethereum or some other blockchain for control. So we can use the Ethereum blockchain for those things that require consensus, such as network coordination and the things I mentioned before, like identity and so on. So what we're proposing to build in the end is actually a decentralized stack for real-time data, for decentralized applications. So what you saw earlier will form the visible part of the stack. We have the Streamr editor, the visual programming environment. We have the Streamr engine that performs the logic built in the editor. Now, how to decentralize that? It's just a process that's running on a machine. So now it runs in a virtual server in the cloud. But what if we actually had a decentralizable computing container? Well, there's a project called Golan that does exactly that. So what we can do is leverage the container that Golan is providing to run our analytics engine inside that container. And further down the stack, there's the Streamr network, which operates on the incentivization of the token. So that's the delivery layer, underpinned by the smart contracts and Ethereum. It doesn't have to be Ethereum. I know this is a Bitcoin conference, so, so forgive me for Ethereum. But we are really all in the same boat, so good. Now, the tokenization of data allows for monetization of data, of course. So the Datacoin can have two use cases in the network. It can be used for incentivization of the brokers, but it can also be used as a means of payment between the data publishers and the data subscribers. What we find is that this space needs middleware, and this space needs tools to grow, to increase adoption. And we find that there are important synergies with other players in the space. For example, Golan I just discussed. We can use Golan for running the analytics. And actually, Golan can use us as well for implementing data access inside the container. So what they avoid doing is opening ports on the Docker container inside the Golan network, because it's an attack vector for many reasons. So what we could do is combine the two, the Golan node and the Streamr node, to enable decentralized computation using streaming data. Melonport is a decentralized asset management platform where traders can easily establish funds and people can invest in those funds. Well, Streamr could be a data source to that system, delivering the prices for assets or some indicators, such as the GitHub stars for some asset. It could be used as a data target to track funds performance, or it can be used as an algorithmic trading platform to create logic that drives the Melonport funds and so on. So I won't go over all of these, but yeah. If you want to follow our project, which I hope you do, we have a Slack where a small but thriving community is starting to build. So please feel free to join our Slack and stay up to date on what's happening with us. We make your streams come true. Thank you very much.
Thank you very much, Henri. Are there any questions on this? It's fabulous.
Wow, it's so hot in here. Oh my God. Are you okay, people?
Still okay. We're almost at a break.
Yeah.
How do you use your stuff? Is it for free, or is there a price, or what is your Streamr platform? How does it work in terms of business model?
Yeah, good question. So it's free. It's kind of experimental and beta for now. Once we release it to the wild, it should be open source soon. Now it's closed source at the moment because we have kind of this legacy business. But before we go embark on the decentralization process, everything will be open source. So you can use our environment and try things, how things work. You can set up your own environment, whatever you want. It's quite likely that we will be the ones that bootstrap the first Streamr network as it will appear in the decentralized form. But anyone can do that. You can set up your own Streamr network for private use or anything like this.
There is a question here in the back as well.
So there's no ICO or investment opportunity here? I like it.
Well, no announcement has been made at the moment. But if you want to stay up to date, join our Slack.
You already have a white paper online.
Yes, we have a white paper online. That's maybe an early sign of something to come. I don't know.
There's another question here.
All right. Sorry. Do you have any problems with legal things like this is going very far in the way that you can see what somebody is doing, where he is at the moment with this structure.
Privacy.
Yeah, well, the way to tackle privacy in this kind of network is, of course, encryption. So our vision is that all the data in the Streamr network would be A, signed, so the origin of the data can be proven easily, and B, encrypted if it's only for certain subscribers. So if you have open data, let's say you're a smart city that's publishing some kind of, for example, the transportation stream or something like this, there's no need to encrypt it because it's available for everyone. But of course, if you're selling something that's private, it needs to be encrypted, and there needs to be a key delivery system in place for the valid subscribers to be able to decrypt.
Yeah, for instance, police cars or something, that you know where they are.
Yeah, for example. If you can provide that data, I'm sure there will be interested buyers for that. And now, since we're operating in an anonymous network, this opens up interesting possibilities.
Thanks. Thanks, Henri. It's very, very, very good presentation.